So why do statisticians say that we can't prove the null hypothesis, that we can only reject it? So you might have heard this in statistics class or online somewhere, that we can never accept the null hypothesis, we can only reject it. And to understand why, this goes back to actually philosophy of science and philosophy of knowledge. So it's an old, a few hundred-year old problem that's called the problem of induction, and it's best explained using the black swan example. So the idea is that no matter how many white swans we could observe in the wild, so let's say we've seen millions of white swans, it's still impossible to affirm that all swans are white, and that statement will be universally true, because we could only need to observe one black swan to invalidate the whole series that we've seen before. So this kind of approach where we try to rather than confirm something is true, we try to falsify it. So this philosopher Karl Popper, he published this book in 1934 in German. So this is like a translated edition that came out later, where he kind of developed that theory of knowledge, and it was really revolutionary for philosophers at the time. And the thing is that before, so there was also this guy, so Ronald Fisher, you maybe heard of him. He's like the godfather of modern statistics. So he published this book also in the 30s, 1930s, I forget the name. But before that, like decades before him and this other guy that wrote this book, so it doesn't have a cover, but Karl Pearson, The Grammar of Science. These two guys, Pearson and Fisher, they were actually like on the same track much earlier, like early 1900s, late 1800s, where they were actually developing what you guys know today as like significance testing and hypothesis testing, where we, compute a p-value and reject the hypothesis of no effect, for example. So it was kind of in l'air du temps, as we say in French, or in the zeitgeist, that there's a sort of asymmetrical relationship between proving something is true all the time versus only needing one example to disprove that something is true all the time. And this thinking has been tremendously influential on the whole scientific enterprise ever since.